to weak acid, strong base titrations, and in these titrations, we are going to plot the pH and the volume of base added, and pH is going to be on this axis, and wow, lots of stuff on the bottom here. Volume of base is going to be on your, pH on your y-axis, volume of base on your x-axis, and as we go, you can plot the pH with each additional amount of base added. The first problem here is just a weak acid problem. We're going to find the pH of acetic acid when I have a 0.1 molar concentration. The weak acid, acetic, HC2H3O2, make sure you know your ions, will break into H plus and C2H3O2 minus. We will do the same process we have been doing with weak acids and make an ice table. They have a concentration of 0.1, and I start with neither of the ions. Because this is a weak acid, a small amount of that acid will break up into its ions, and I will end up with equilibrium concentrations like so. I will then write my Ka expression, which is products over reactants raised to their coefficients, and the reactant is like so, and I can look up the Ka value of my weak acid, acetic acid, which is 1.8 times 10 to the negative fifth. I'll plug in my values, x times x, or x squared, over 0.1 minus x. Because this is just a weak acid by itself, we are going to assume that this x does not have a significant effect. And so when I solve x, right over here, x will be equal to 1.3 times 10 to the negative third. Don't forget that you do want to check that 5% rule and divide it by your initial amount, your 0.1. You'll find out that it's not going to have an effect, but you just don't ever want to forget to be thinking about that. And then pH is going to be negative log of your hydrogen ion concentration, which is x, and so x is 1.3 times 10 to the negative third, and the pH of this weak acid to start is 2.87, but because I only have one digit or one significant figure in my concentration, this would round to 1.9. For the rest of this problem, though, I'm going to add this. I should have put that in my PowerPoint, but I forgot. So I would like 2 digits to the right of the decimal for pH. Now to that weak acid, we are going to be adding 10 milliliters of a strong base. Whenever you add a strong acid or base, that reaction is going to go to completion. So the reaction that is taking place here, I'm just going to move this down here. The reaction that's going to be taking place here is our weak acid, and I'm just going to write it as HA. That's our lactic acid, acetic acid, so that I don't have to keep writing this big long thing. And I add hydroxide to it. That reaction is going to go 100%. That reaction is going to happen. And so I will get water when the hydroxide pulls off the hydrogen and the anion. And just for reference, that anion is the acetate ion. I just don't want to write it out all the time. Okay? So this is the reaction that's going to be taking place. This is 100%, so now I need to know how many moles of each of them I will be starting with. So it tells me I have 50 milliliters of 0.1 molar acetic acid, so 0.1 molar, 50 mils, or 0.05 liters, and when I solve, I will get 0.005 moles of the HA. Okay, so if I put that here, it's going to be 0.005. Okay, for the base, I'm going to be adding 10 mils, so that's going to go on the bottom, 0.01 liters, and the concentration of my base is 0.1. So when I solve for moles, that's going to be 0.001 moles of the hydroxide. because I know NaOH breaks up 100%, and the Na plus, ooh, the Na plus has no effect on the pH. Okay, so now I know the number of moles I start with. I have to look at the limiting reactant to figure out what my change is going to be for this reaction that goes 100%. Remember, we don't care about liquids, and I start with none of that anion. Limiting reactant, hydroxide. So I'm going to use up 0.001 of each of those, and I'm going to make 0.001 of that, leaving me with an end amount of 0.004, none of this, and 0.001 of that. So the last step down here is, now I have this weak acid and its conjugate base, and they are going to try to find this new equilibrium position, and to find that I need to use my Ka expression. And products over reactants again. So maybe I'm going to write it out here first actually. So this new equilibrium is going to look like that. And I can make an ice table for this. And I start with 0.004 moles of this, none of this, and 0.001 moles of that. Because I have no hydrogen, I'm going to lose and gain here. And I'm going to have 0.004 minus x, x, and 0.001 plus x. So to solve my Ka here, it's products over reactants, so 0.001 plus x over 0.004 minus x, and since x should be much, much smaller, I'm going to say that it has no effect. My Ka value is 1.8 times 10 to the negative fifth, and I can solve for the x, and I will get x equal to 7.2 times 10 to the negative fifth molar. And then the final part of the question is, what is the pH? X represents the H plus concentration, so it's going to be negative log of 7.2 times 10 to the negative fifth, and so the hydrogen, or the pH of this substance is 4.14.